Okay, so since you know that arctan, so the derivative of arctan is 1 over 1 plus x squared, or it's written as the integral of 1 over 1 plus x squared is arctan. Okay, now it says find a Maclaurin series expansion for arctan x. So what it means is we're going to do term by term integration. Okay, so arctan x is equal to integral of, whoops, what's inside here? Well, recall we have 1 over 1 minus x is 1 plus x squared, which is the sum. This is what it is, okay? But we don't have minus x. So what we do is replace x with a minus x squared, right? So the minus is a little tricky. Because there's a plus here, you get a minus up there. It's just one of those, you know, algebra things. Okay, so then you're going to get minus x squared to the n dx. Okay, so that's the important realization. Now, this is still a little tricky, so I'm going to, what is this, n equals 0 to infinity, right? There we go. Now, I'm going to put the minus 1 out separate from the x to the 2n. It's first of all, it's standard procedure to do that, but there's a reason why it's standard procedure. Negative signs are a mess. I mean, think about it. What is the additive inverse of 3? It's negative 3. Negative 3, we just write it as minus 3. But it's kind of profound if you think about it. We use all the same symbols for the positive and negative numbers. We didn't have to do that. Okay, so here we go. We have minus 1 to the power of n, and that's just going to toggle plus minus 1. And we don't want to try to put the n down, what, n plus 1 and all this stuff, because then we're going to have to multiply by the derivative of what's inside, which is going to be like 2x. It's going to be a mess. It's much easier to do it this way. Okay. So let's go ahead and do it. Right, so, oh, and we have to remember the plus c, right? So we're going to have this stuff going on, whatever it is, and then at the end we're going to have a plus c. Right, so the minus 1 just comes along, and now we have to take the integral of just x to the 2n. And that's going to be x to the 2n plus 1. Now what? Okay, we're going to divide by 2n plus 1. Let's take the derivative to make sure that it works. Those two guys multiply together to cancel each other out, right? Subtract 1, you get back to 2, and yes, we're good. Okay, and so that's not that exciting. Ah, yes, but what is the plus c? Well, we know that tan of 0 equals 0, so that means arctan. So tan and arctan, one is just the inverse of the other. They both go through the origin. So tan is going to look like that, and arctan, this guy, yeah, I can't do that. Okay, anyway, arctan is going to look kind of like that. Pardon the bad picture, but that's roughly what it looks like. So that means that this constant is gonzo. Goodbye. And if you want to write some terms out, it might be nice, but you don't have to. Maybe later I tell you to. I don't know. Oh, I tell you to later in a slightly different context. Okay, so let's see. If n is 0, we're going to get a single positive value, and then we're going to get x over 1. No big deal. It's going to toggle, and we're only going to get odd powers. Alright. It looks much nicer that way, doesn't it? Okay. Now it says, what about pi? What about pi? Well, arctan of 1 is pi over 4. So 4 arctan 1 is equal to pi. So we just say, well, bring this guy, all these guys down, then you have 4, oops, be careful, 4 times 1 cubed not 4 cubed. So this is the arctangent expansion for pi.